Okay. Good afternoon, everyone.
Good
Good
afternoon.
afternoon, sir.
Good afternoon, sir.
Walaikum assalam. So hope everyone is fine. So where are the rest of the students? We have only 23. What happened to other 22? Because it is raining, that's why.
Yes, sir.
Maybe, sir.
But generally, whenever it's a conventional class, whenever you are late to the class, you always say that it was raining, there was a traffic jam, or there's some problem. But in online class, how come the rain can affect the class?
Sir, this is an innovative idea, but just we are thinking it's a broadband connection. Maybe this is why that is got disturbed.
So you need to connect. You need like it is almost 5 minutes. So you need more than 5 minutes to connect it. Very good.
No, sir, that's not true actually.
Anyway, so what we have discussed yesterday. First, it was the second class. Your section C, yeah, okay. So we have discussed. I think system dependent and system independent, right?
Yes, sir.
So so hopefully you have understood. Hopefully you have understood. We have whatever we have discussed yesterday about the system dependent and system independent. Can anyone just give me a very brief idea about whatever we have discussed so far about the system dependent and system independent? About this is level 0 to level 5. Very briefly. Anyone?
Sir, may I?
Yeah, sure.
Sir, we learn about system dependent. Level 0 to level 3 is basically system dependent. System dependent means whatever we do, it will depend on our current system.
Mhm.
And system independent means whatever we do, it will not depend our current system. It will run same as for every system. And as a hardware level, we learn about hardware level. Why hardware level is system dependent, operating system, machine language, assembly language, and some examples that we learn.
Yeah, okay. Good. All right. Thank you. Yes. So we have discussed a little bit like last class. We have just discussed only this, that what is system dependent and what is system independent. So you might think that why we need to know that, right? What is the reason that we need to have the idea of this overview of computer? Because as I guess that most of you are going to be a software engineer as a profession in the future very soon. So whenever you are going to write a program or whenever you are going to do your job in a software company, so you cannot expect that the rest of your life you are going to code in only one platform. You never know. Whenever I start my first job, it was in a software firm. I never thought at that time that I'd be a teacher after 20 years. And then I started with the software company and I didn't like it because I really don't like coding. Anyway, then I changed the profession and that is a different story. But for you, you never know in which platform you are going to do your work or going to do your coding. So it is always better and safe and of course necessary to know all the system. If you know all the system, then it's not a problem for you in the future, then where you are going to do coding. So please do not expect that the rest of your life you're going to do on C, Java, C++, HTML, CSS, JavaScript, Python, or any kind of so-called framework like Laravel or WordPress or whatever. All right, so it cannot be like this even for the rest of your life. So it can change and you need to update yourself. You need to upgrade yourself. So it is the safest option that we should have a proper knowledge, at least the idea about the whole system, so that whenever anything happens or any requirements for doing the code in any platform, so that we can have the basic idea. Whenever you have the basic idea, based on that basic idea, you can improve yourself. All right, so that's why it is necessary. That's why it's necessary. For example, you are not a software engineer. You are you will be a network engineer, or maybe you are a hardware specialist. Maybe you are an IT specialist. Maybe you are a telecommunication engineer. Whatever you are in the future, obviously, every time, all the time, you must know about your system. Okay, so that's why we need this. Most of the time, students ask me that, why should we learn this? For example, why should we learn assembly language? Like, why should we learn microprocessor? If I'm going to be a mobile app developer in the future, if I'm going to be a graphics designer, let's say, for example, why I need to know this? The answer is, whenever you do the graduation, first of all, you are doing a graduation of CSC, and it is a requirement. That is the first reason, that it is a requirement to know all this about the computer, like processor, memory, architecture, and everything, and the coding, and the networking, hardware, and everything. It is the requirement to be a CSC graduate. That is the first reason that we are doing this. Second reason is, in the future, as I said just earlier, in the future in your career, you never know that which part of your study during the graduation will be very, very important in the future career. For example, why I'm saying this, because I have personal experience, that's why. When I was a student, a long time ago, you know that, 20 years ago. So at that time, we have done so many courses. I was thinking what was the reason? We are so angry and we're not happy about it. Let's say, for example, we have done the BBA course. We are so annoyed about that why we need to do a BBA course, because we are going to be an engineer. Because, whenever your first semester, second semester, or the first year, you are very excited about it, that you are going to be an engineer or whatever. So at that time, we had that kind of excitement that we are going to be an engineer. Why we need to know, why we need to study BBA. So, and in that courses, we have done like budgeting, debit, credit, accounting, economics, so many things. So many things we have studied in that course. So during that course, we actually never feel that why should we do this? But after completing the course, do you know what happened? If I can tell my one. After doing that course, is actually after CSC, the economics is my second favorite topic or subject. If I'm not going to study the CSC, obviously I'm going to study the economics. It's that much interesting to me after that course. So, and there's the one reason. Second reason is, as I said, that I have started my first job in software firm. So my first assignment in that job was to make a software. It's an accounting software. I have to make an accounting software for another company, and we have to sell this. So we are a CSC graduate and we don't know anything about accounting. So at that point, I understood that yes, we have done one course related to the BBA or the accounting, economics, debit, credit, so many things. We have learned it. So you just recall something, whatever we have learned, and that is easy for us. So think about it. If we don't know anything, if we didn't do that course during the graduation, in my first job, in my first assignment, it will be difficult, impossible for me. I have to learn again. So that is just a small example that during the graduation, whatever you are going to learn or whatever skills you are going to acquire, it will be needed in some part of your life. All right. So don't think and don't question that why you are doing this, why you are studying this, and don't study in an approach that, okay, I just need to do this course for my graduation. So I don't need it. So just memorize it, write it in the exam, copy paste, do cheating, whatever, just pass the course and forget about it. Please don't do that. All right, so every single course you are doing, which is important. Maybe you are not feeling that importance right now, but you will feel the importance whenever it will be needed in the future. All right, this is my personal experience, so it can be the same for you as well. Okay, Amit Hassan, what is it? Sound is breaking. What can I do? Is it the same for all of you that you cannot hear me properly?
No, sir, it's okay.
No, sir, it's okay.
Okay. Maybe there is a, the weather is not good. Maybe you have some problem with your wireless connection. Maybe the reception is not good. So please wait a little bit, Mr. Amit Hassan. It can be, I think it can be all right after some time. Okay, so that's why, okay, so please, I suggest you or I request you that whenever you have any course, I know you are doing so many courses, like psychology, like economics, like ART, like so many courses. I know that. There must be a reason behind every course. Do you know where during my graduation, I did Bengali? We have to read 5 poems. I don't know why. 5 poems we need to read and study and analysis. Still, I don't know why, but maybe there must be a reason. The reason may be, I don't know, maybe you should have learned your mother language very well, your culture very well. Without having your culture, and it is part of your life, so you should know your culture. Maybe that is the reason. I don't know. Whoever designed the curriculum, they know better than us. So it is fine. So I have learned a lot of things. So it is also better for you that do not question that why should you learn this one. And there must be a reason. There must be a reason, and for every course, ART 103, ART 101, whatever, psychology, philosophy, statistics, economics, English, math, physics, chemistry, so many courses. So every courses have some importance. Okay, all right. Amit Hassan, you raise your hand again. What is the reason? What is the problem? Or Amit Hassan? Can you hear me, Amit Hassan? I'm not sure, Mr.
He mistakenly muted.
Okay. All right. So let's go to the next topic, which is, if you remember that I have told you that we are going to discuss two processors. If you remember that in the first class, I have discussed that in this course, we are going to discuss two different types of processor. One is the CISC, CISC, you can see that it is written here, CISC processor. Another one is the RISC processor, RISC, this one, RISC, RISC processor, and the CISC processor. Nowadays, category and RISC, all right? So this is the full form of the CISC, complex instruction set computers. There is a reason. Okay, it is better, yes, you have to memorize this one. Complex instruction set computers. There is a reason why it says complex. We will discuss why. And other one is the RISC, reduced instruction set computers. So one is the complex instruction set, CISC. This one is the reduced instruction set computers. That means if you think about the complexity of the code, which one is the less complex? This one, right?
Yes, sir.
Sure.
because this is reduced instruction set computers. RISC. So if you think about the complexity of the code and the length of the code, obviously this one should be the less one because the name is reduced instruction set computers. And if you think about the CISC, it says complex instruction set computer because it's a little bit complex compared to the RISC. So that is this processor, as I said, that our Pentium processor or any processor which you are using in your laptop or PC or wherever you are. Okay, Mr. Ramita-san, no problem. So that is the example of the RISC. Let me show you the example. These are the example. You can see most of them are Intel. Some of them are Motorola, although it's very few uses of the Motorola families, but we are going to use this family. Oh, by the way, we call them family. Look, they have written x86 family, Intel 8051 family. So why we call them family, by the way? Because this is not just one processor, it is actually a group of processors. Right? x86 8080 is okay. Intel 8080 is the first processor from where we have started our upgradation. Nowadays, we have 10th generation of Intel processor. But that was the first processor. We will discuss very soon about the whenever we are going to discuss about the Intel processor in chapter number 3, we are going to see the history of this Intel processor from this first processor until our current, very recent 10th generation processor. All right. So there is a list. We are going to show this one in chapter number 3. So wait until that. Or if you're very curious, you can go to chapter number 3 and read yourself, or the slides I have given, the processor slides, third one, that you can also read from there. So these are the example of the CISC processor. Generally, as I said, this kind of processor is much more powerful than the others. And it requires more energy because it needs to do a lot of tasks. It needs to do a lot of tasks and more tasks compared to the other RISC processor, right? I will show you the example, then it will be easier for you to compare between these two. Look at the example of the RISC processor. Okay. You might not know all of the name, but okay. ARM is a very common architecture. By using the ARM, your mobile processor is built. All right. There are some other examples as well. Look, there's a supercomputer. Some of the supercomputer, I think you know the supercomputer has so many processors. So many processors, not just one. So many processors to make one supercomputer. Unix workstation, embedded system, our printer, router, small devices, and of course our ARM architecture using our smartphone and tablet computer. Most of the time is the iPad and the Android device. That means generally instead of this supercomputer Unix system, instead of these two examples, rest of the examples of this RISC processor is actually based on the smaller devices where we need less power, where we need less energy. Because whenever you try to write a code in these types of processor, you need to write less number of code compared to the CISC processor. In the CISC processor, we need to write lengthy code. This is the example of the Pentium. I'm just giving you the example we will discuss tomorrow. This is the example of the CISC processor, which is a Pentium processor. And this is the example of the RISC processor. very briefly, anyway. So I'm just giving you the example, that's why. Okay, let me start with the CISC again. Why I'm showing all of this together so that you actually have an idea, actually as an overview that CISC generally using in laptop or PC or high-end device where we need more power, where we need not more processing power. Generally, on the other side, the RISC processor, except you, as I said, except the two example you have seen, that supercomputer and the Unix computer, except that rest of the examples are related to the smaller device. So generally, we use the RISC processor, RISC, we use in a smaller devices where we need relatively less power and relatively less processing efficiency. There is an exception now. So don't get confused, all right? I cannot blame you if you're confused. Nowadays, all right? Nowadays, today's technology is now shifting from these two classifications. Today's technology, if you think about the Intel 10th generation processor, if you think about the AMD Ryzen 5, 6, 7, 8, these are the processor for the AMD. And if you think about the Intel processor, it is all a 7, 8, 9, 10th generation processor. All right, so if you think about the recent technology, now the manufacturer, especially these two, now the manufacturer wants to shift from all the processor, from the shift from CISC to RISC nowadays. That means they are new processors. Most of the time, many of the model, they use RISC architecture rather than CISC architecture. All right, so the most recent one, but theoretically, previously, we do opposite. All right, so there is a little bit confusion. So don't worry about the confusion. This is just for your knowledge that theoretically and previously, and most of the time, just previously, like 3, 4, 5 years ago, the processor always divided into two parts. Most of the time, CISC processor is our Intel processor, which we use our laptop, PC, or workstation, and the RISC processor generally used in our smaller device where we need smaller power or it requires smaller processing ability. For example, your router, your printer, your washing machine, your lift panel, refrigerator, your mobile phone, something like this. Okay, so that is the theoretical thing. But practically, if you think about now, recent technology, I told you this book is 2004, 17 years ago. And the technology of the processor, especially the technology used by the manufacturing companies, especially Intel and AMD, they are now trying to shift that. Not everything they have shifted, but still they are producing the processor related to the CISC for the computer. But many of the processor, as far as I know, that they are trying to shift it to the RISC type of the processor, which you are going to use in our laptop or PC very soon. All right, so that is a little bit of contradiction. But the rest of the, I'm just telling you for your knowledge, for your understanding, because I told you, it is not good that you just memorize something without knowing it or without knowing. There is a problem of this profession that there is no fixed thing in our computer engineering. There are two problems in the engineering and the doctor, medical doctor. In these two professions, you cannot certainly say that, okay, this is the fixed thing. Never say that. Cannot say that. Because for us as an engineer, I mean electrical, computer, civil, mechanical, all of them, you cannot say this is the fixed rule because technology is changing, innovation is changing. So every time it's actually shifting and changing and everything. Although the basic things are same, although the basic things are same, but they keep changing their technique. So we cannot just say every time that, okay, this is a fixed thing and it will never change. You cannot say that. For the medical doctor also, they cannot say that, okay, this is the fixed rule. That's why we have this kind of disease, new disease, nobody knows. So it is keep changing. So the technology and the medical field is actually keep changing. That's why you have to keep updated yourself. If you study a book which is like 30, 40 years ago, and if you think that that is the technology, no point. Absolutely no point. You should know the basic thing. Whenever you study, you should know the basic thing, and then you should keep updating. Keep updating yourself based on your basic knowledge. So whenever you have a basic knowledge, the point is, whenever you have a basic knowledge that what is a CISC processor and what is a RISC processor, and which type processor are CISC and which type processor are RISC, if you know this one, that is enough for this course. Then it is your duty after doing the course that based on the shifting of the technology, you should read the newspaper, you should watch the video, you should read the review or the tech or the magazine or everything, and then you should keep updating yourself. My experience, whenever I first start my PhD in 2014, 1st of June, at that time, I told you, there is nothing, nobody knows about 5G. So nobody has imagined about 5G, according to my knowledge at that time. That time, it was just released 4G. And we are keep updating the 4G. So I was thinking that, all right, now it is just launched the 4G. What will be the next version of 4G? So let's work on that version. So I choose 4.5G, which is LTE advanced. At that time, there was very, very few researchers was working on this field. I'm talking about 2014, 1st of June, or June, yeah. All right. Now, nobody cares about 4G. Nobody cares about 4G. There are very few people, although they are publishing right now, although there are so many other researchers, but nobody wants to publish related to anything about the 4G, because now everything, whole world is now shifting from 4G to 5G. You will be amazed that a very big part of the world of the research is also trying to shift from 5G to 6G a long time ago. Because I saw that I was amazed. I didn't even imagine that it can be possible. So they already proposed a model, so many models. The proposed model for specific reason for 6G, which is amazing. I don't know even about 5G yet properly. We cannot see 5G even properly. There are so many countries who doesn't have the 4G properly, including our country, but they are working on 6G. So see how fast this keep changing everything. So if you want to study, let's say you want to do a master's on 4G, no point. Right. So the bottom line is why I'm saying all this, because our technology, our field of study is continuously changing. Or it's continuously changing. So what we need to do, as I said, we need to know the basic thing. Right? Currently, what is the current technology? According to the current technology, we need to know the basic thing. Then based on your basic understanding, then you update yourself according to your need. That's what we need to do. For example, in my case, I have studied my PhD graduation 3.5 years on LTE advanced, which is based on 4G. But now, as I said, everything is moving from 4G to 5G and now 6G. So it is not like a completely new thing about 5G and 6G. It's actually the updated version of the 4G. 6G also, it's just updated version of the 4G and added some new features. Right. So if I have a basic knowledge about 4G, now I can upgrade myself. Now I can read more so that I can understand 4G, 5G. And then I need to upgrade myself furthermore so that I can understand 6G and more and more. Same to you. We are going to learn about CISC processor, right? So what is the CISC processor? How does it look? Which are the CISC processor? Although you can find out, as I said, that some of the processor like this one, Intel 8080, Intel 86 family, Motorola family, Intel 8051 family, these are very old processors, like 1969, 1979. Then, based on this technology, Intel upgrade themselves. They upgrade themselves based on the processor, this processor. That's why sometimes they say that Intel 8080 processor is the mother of all the processor which we are using currently. All right, similar types of technology, but they upgrade themselves. Previously, their transistor has some centimeter size, but nowadays, their transistor size is nanometer size, 10 to the power minus 9. That's how they have shifted. Previously, we have only one core of the processor. Nowadays, we have 8, 16. My one is octa-core. No, I don't know. Maybe 6-core. I have 6-core maybe. My mobile phone maybe has octa-core. Your mobile phone has maybe octa-core. Octa-core means you have 8 layers. Right. So that is the point. That is the point that we need to know. So you might ask me the question, sir, this is very old technology. Why should we learn this one? You should learn this one because this is the basic one. Then, based on this basic knowledge, you can upgrade yourself. That is your responsibility. All right. So this course responsibility is just to introduce you to the basic knowledge. After that, you can upgrade yourself. All right. So, any questions so far? Please stop me because I don't have any watch. Where is my watch? 1:46. Okay. Any question?
No, sir.
No, sir.
Fine. All right. So CISC processor. So in the CISC processor, we know that it's a complex instruction set computers. In short, CISC. Right? You can see that it's a single instruction can execute several low-level instructions. Okay, no problem. I will explain. Don't worry. I'm capable of multi-steps operation. Okay, that means this is more complex. That's why the name is complex. I will show you the example. Okay. So let us see some advantage and disadvantage. So we know that CISC processor is complex. That's why the name is complex. And of course, we compare the complexity compared to the other one, which is the RISC processor, right? And inside one, as it says that whenever we write a code on CISC processor, inside this processor, we actually have several other processors hidden. You don't need to write it. Okay, you don't need to write it. It's already there. Whenever you write a code on this, it's actually a combination of other several low-level codes as well. Okay, and these codes are, as they have given example, like some arithmetic operation, some memory operation, something like this. Okay, so that's why it's called complex, because just one line of code represents so many other several low-level instructions, or they say operations. That's why it's called complex. Although it says it's simplified, but because why we call it, but inside that one line of code, you actually have several other codes. That's why we call it simple, but it's actually not simple. All right, so that's why it's called complex, because one line of code is combination of other several low-level operations or low-level activities. Okay, so let's see some advantage and disadvantage. As we can see, as already that these are this is our example. Some Intel processor and some Motorola processor. What are the advantage we have of this CISC if you compare with the other processor? Obviously, as I said, the code size is not that much big. It is shorter because one line of code can represent a large number of code. So you don't need, let's say, for example, you want to do one task. If you want to write the same code to the other types of processor, you have to write 5 lines. But here, you just need to write 1 line. Okay? Execution of a single instruction with several low-level tasks. As I said, that 1 line of code is actually combination of several other load, which we don't need to write. The computer will understand and then execute one by one. That's why it takes more time, right? That's why it takes more time to execute one single line of 6 types of processor code. Because 1 line of code is not just 1 line, it's actually a combination of others. That's why it takes more time. Okay, you are not going to understand about the addressing mode and everything, so don't worry. I just listen that it's actually have a complex addressing mode. We are going to discuss in chapter number 2 what is addressing mode and directly access to the memory. Yes, that is the biggest difference. Whenever we are going to discuss about the RISC processor, it will be opposite. Sys instruction can directly access to the memory. Right? No need any permission, but for the RISC it needs some via some other. So that is the difference. Whenever we compare about these two, we will see this one. Okay, so just remember now that CISC processor can access the memory directly. So basically, these are the advantages. So the advantages are the core size is small comparatively. One line of code is actually a combination of several other low-level language and not language, task or operation, and it can access the memory directly. That is the advantage. Let's see the disadvantage. It has disadvantage, as you can see. It is very common, like common sense that although the code line is just 1 line, but it is combination of several other code hidden inside it. So that's why it requires more clock cycle. I hope you know what is clock cycle, right? 1 clock cycle. For example, just one frequency, right? For the processors, it requires more time. Fine, because it is not just 1 task. It's actually a combination of other tasks. That's why it requires more time. They say clock cycle. So for the microprocessor, the time is actually the unit of clock cycle. That's why they have right clock cycle. You know that. We will also discuss this clock cycle separately, so don't worry. Okay. So it says that although it is written just 1 line of code, but it's a combination of other multitask. I mean, other several tasks inside it. That's why whenever you do the pipelining for the processor, it will be a little bit difficult to handle. Okay, what is the pipelining? Because this is the technique or tools by which you can execute the instruction one by one. You will know more about the pipelining in your microprocessor. But very briefly, generally, the pipelining is one technique by which you can execute the instruction one by one. That's pipelining. All right. So whenever you implement the pipelining, so it will be a little bit difficult because one instruction requires more clock cycles. So whenever you try to manage this kind of queue, so it's a little bit difficult to manage the queue. Okay, and of course, the hardware should be supported this kind of code. That's why the hardware is not also that much simple. All right. I think the most Considerable disadvantage is the last one. That is the most significant disadvantage of the CISC processor. The last one. What is it? It says designed to minimize the memory requirement when memory was smaller and costlier. But today, the scenario has changed, and nowadays memory is inexpensive, and mostly all computers have a large amount of memory. See, I told you that whenever it was invented and whenever it was used, at that time, the technology was in one position, but now the technology is actually shifted. So that's why I said the last one is the most significant one. It says that wherever it was designed, the CISC processor, whenever it was designed at that time in 1970 or 80s, at that time, the memory was too short. We don't have that much of memory. On my first computer, my memory was 120 megabytes in 2002. Nowadays, you can buy 120 gigabyte memory, no problem. So at that time, 128, I cannot even imagine that memory can be 1 gigabyte at that time. So we always think that, okay, maybe it is, that is the best. But at that time, 128 and 256 mega was the best memory. So the same thing, at that time, memory was not that much easy to get or that much cheap. So whenever this CISC processor is designed, it's designed in that way that we use less amount of memory. That's why the code is so complex, so that it can squeeze it into the smaller memory size. But nowadays, we have very large amount of memory. We don't have any problem with the memory. So that's why this kind of processor nowadays is not that much popular. That's why I have said earlier that nowadays the company don't really want to make their processor in this CISC processor. They try to use the processor for the RISC processor. That is actually the biggest reason. All right. Is it someone is calling me from your section?
Yes, sir.
Do not call me.
Maybe, sir.
Please do not call me during the class at least. It is better ask your friend to inform you that they have disconnected, and you will just inform me. That will be enough. No need to call me. Okay. It is better if you are disconnected. It can be happen. If you are disconnected, just inform your friend who are in the class right now, and you will inform me so that I can let you in. All right. By the way, do you understand until this point about the CISC processor?
Yes, sir.
Any question?
Yes, sir.
Yeah, any question?
Sir, I have a question.
Sure, sure.
In the advantages, I didn't understand the second
Advantage.
line. Yes, sir.
Which one?
Yes, sir. The second one. Execution of a single instruction.
Execution of a single instruction accomplish several low-level tasks. Okay. Previously, I have said that in these types of microprocessor, you can see that CISC is a type of processor where single instruction can be executed several low-level operations. That means whenever you write a code into the CISC types of processor, that code is actually combination of other several code. That means if you want to do one task, you need to write 5 lines, right? But instead of 5 lines, you just need to write 1 line in these types of processor to save the memory. That means one single line of instruction is actually combination of several other instructions. Especially it is, as you can see, such as load from the memory, write from the memory, arithmetic operation, and of course the memory store. That means one line of code is combination of everything. That's why you just need to write one line of code instead of several other lines of code to do one task. That is the advantage. I think that is the same way the advantage and the disadvantage. Because whenever you have just need to one line of code, so that is the advantage, that you don't need to write 5 lines of code. One line of code is enough. That is an advantage. At the same time, it can be disadvantage, that first one, because you just need to write one line and it will be complex code and it will take more time to perform. And sometimes it reduces the performance of your computer as well, because you need more time to execute one single instruction, because one single instruction of these types of microprocessor is actually combination of other several instructions. All right?
Yes, sir.
Yeah, it is not that much, maybe that much fast you can understand. A little bit time, it will take a little bit time to visualize what's happening. So it is better you listen to me and then, of course, read a little bit from the book. It can be very, very easy to understand. If you still have any question, you can ask me, by the way. But that is the overall. Remember, in the book, they have written so many other description as well in a very, very nice and easy way. I have just given just a summary, because it is not possible to write everything here, right? So just give it a summary. So if you want to know more about it, if you want to have more discussion or more description, it's always better to check the book, or I have given the reference at the last slide here in the Wikipedia, of course. It's complex instruction set computer, that is CISC, and reduced instruction set computer, which is the RISC. You can go there to the Wikipedia. It's the easiest option, and you can read a lot of description about it. Or you can go, this is the Stanford University website. You can go and learn from there also. They have also written in a very nice way. Or you can go to the textbook. You actually need to read. It is not easy, really not easy, and a little bit confusing, because as I said, that it is confusing that second advantage at the same time it is an advantage, and it is at the same time is that it is an advantage. So it is a bit of confusing. Sure. So until this point, please ask me question if you have any.
Sir, I missed the attendance.
I didn't give the attendance yet.
Sir,
Yeah.
sir, I want to know a thing that not related to this topic. Sir, you said nowadays the engineers have trying to shift to CISC processor to RISC processors.
Yeah,
So-
not the engineers. Okay, not the engineers, manufacturers.
Manufacturer. Okay, sir. I want to know that, sir, we have read that in supercomputers there is a lot of processors.
Yeah.
So are there any possibilities that these computers might have more processors?
Yeah, you can see that RISC processor are also used in supercomputers. Look,
Yes, sir.
in supercomputer, there are thousands of processors, right? So they used actually already, they have used the RISC types of processor in the supercomputer. Maybe they think that it is much more easier, because in a supercomputer, you have to manage all this. You have to write a lot of code. So it's better and easier, and it requires less amount of memory for the RISC processor. Maybe that's why they have used the RISC processor in the supercomputer. And nowadays, the manufacturer shifting from CISC to RISC because of the complexity. Look at the disadvantage I have said. Whenever the CISC was designed, it was designed for the smaller memory, to save the memory. But nowadays, we don't need to save the memory. We have a lot of memory. That's why the manufacturer thinks that why we go for the complex option. Whenever we have a large memory, we don't have any problem with the memory. So why we go for the complex option? We go for the easier option, which is the RISC. Maybe that is the reason. Maybe that is the reason. There is so many other reasons, but that is maybe the biggest reason that the manufacturer actually trying to shift from CIS to risk. Because that's why I told you that disadvantage number 4 is the most significant one. You just read it carefully, you will understand that why CIS is really not good enough right now. Maybe in the very near future, nobody will produce any CIS processor. Everyone will go shift to the risk. Maybe very distant future, they will categorize another type. You never know.
Yes, sir.
Okay. Any
Thank you,
questions?
sir.
All right. Any questions so far? No? By the way, don't you think that it's interesting, the course, the topic?
Yes, sir.
Should be. Anyway, all right. So let me, if there is no question, then let me give you the attendance. Please read it from the book, all right? It is better always read from the book. Otherwise, it will be difficult for you to understand, because I have just given a very short summary, and this short summary is not enough to understand. So please read it from the book. It will be much better you read from the book to understand it properly. Okay? Yes. Otherwise, you might not be satisfied about the description I have just given. And before your memorization, please try to understand what you are memorizing. You are section C. I forget every time. Section C. Okay, CSC 197, section C. Please respond, Shakil Ahmed. Mominur Rahman.
Yes, sir.
Saidul Islam.
Yes, sir.
Moinul Islam.
Yes, sir.
Himel Shortcut.
Yes, sir.
Shariar Haq. Shariar Haq. Ademul Haq Rani.
Present, sir.
It Hassan.